For this next session at the Mobile Edge Forum, I'd like to introduce Mr. Bejoy Pankajakshan, Executive Vice President and Chief Technology and Strategy Officer with Mavenir. He's going to talk to us about distributing intelligence out to the edge of the network and how that links up to new service revenue opportunities for operators. So with that, I will hand it over to you.
Hi, thank you. And thank you for having Mavenir to present here today. It's an important topic which many operators are looking to monetize. If you look at 5G and some of the early services that operators are looking in terms of monetizing, one of them, of course, is FWA. But in addition to FWA, there are many use cases around cloud gaming and others where a better user experience could be delivered to the user using edge computing. So my presentation today is going to focus on edge intelligence and APIs, and more importantly, how some of the newer technologies, for example, Open RAN with radio intelligent controller, can play a key role in delivering this edge intelligence. As far as the agenda, I'll first talk about some of the trends that we're seeing right now in edge computing. Then I'll go into the intelligence controller concept, which is the way you could manage applications at the network edge. And finally, the edge economy and how important the API story is to actually monetize edge applications at the end of the day, because that's what operators are looking to do, is monetize the services that they could offer at the edge of the network. So very quickly on edge computing growth, when we look at some of the market information that's out there, and this is one market in particular where if you look at the report from TBR or Dellero or Media or RCI Wireless or Light Reading, the numbers are so varied because what goes into the total addressable market for edge computing is counted differently by different players. In this particular chart that I've chosen, which comes from TBR, they've used, as far as computing, the compute spend for edge computing, they've used the services that comes from mobile operators, from cable providers, as well as from the hyperscalers. So if you look at the number right now, it's saying 2022 is 26 billion spent. And that comes from all the edge infrastructure that these three parties, the MNOs, the cable operators, and the hyperscalers have spent. And the trend, if you look at it, it's growing pretty well, expected to hit around 75 billion by 2025. And some of the key drivers there, obviously, disaggregated open networks would lead to deploying more applications at the edge of the network. The whole industry transformation, be it for industrial applications like edge robotics, or private cellular adoption, where previously it used to be all Wi-Fi driven enterprise connectivity, which can now change to cellular-based connectivity. That's another driver. And of course, if you look in general, 5G, China has been the most aggressive in terms of rolling out 5G services. So all the digitization initiatives that China has, that's helped this market. And the fact that 5G is more open and disaggregated also brings in new system integrator and players. So SI players, shared infrastructure owners, and the investment that they're making. So that's some of the key drivers that we're seeing in this market. As far as detractors, of course, for this market to really take off, you need more players entering the ecosystem. And that means open white box hardware rather than custom hardware. So if you're going to deploy new hardware at the edge of the network on the enterprise location, the whole concept of universal CPE devices come in, which is an edge white box solution. Then you have standardization. I'll cover this in a bit more detail. It's actually a plus and a minus here because there's a lot of activity happening through different initiatives, open source community, standard activities through GSMA, 3GPP, and other bodies, but there doesn't seem to be a cohesive story across all these different organizations yet. And because there's fragmentation right now in this ecosystem, it's also delayed the adoption and how the services get sold to the end user, be it the long tail developers or the consumers or the enterprises. And finally, just like any other service, the aspects around chip shortage and supply chain related issues have also taken, is also another reason why edge computing market has not grown at the rate that some of the earlier predictions have made. As far as the different category of applications and what are the drivers for these categories, we look at network application. My presentation is going to be skewed more talking about how network applications can be tuned to deliver edge applications. There's also vertically integrated applications, be industrial use case around robotics, remote site inspection, inventory management, which can all make use of edge computing. And of course, finally, with more machine learning, deep learning, and AI use cases, You have better customer-facing applications also that leverage edge computing. So some of these are AR, VR, telehealth, video streaming. Of course, mobile gaming is another big one. And the drivers for these different category of applications are the same, be it new revenue opportunities by selling these new applications, a better experience for the user in terms of improving the quality of experience, or QoS, be it lower latency or higher throughput that's delivered to the user. And finally, because these services are delivered at the edge, and being able to deliver this with greater service predictability. So again, goes back to the quality of service, the quality of service level agreement, validation for the user. So these are some of the key drivers that we see, as well as the applications for edge. Again, looking at some of these segment findings for this market, today, if we look at how the application is being processed, less than 10% of the traffic is actually processed outside of a traditional data center, which comes from the operator. And if we look at 10 years out, the projections that I've seen, it talks about up to 75% of the processing would actually happen outside of the traditional data center. So, and what's driving this is the need to have faster data distribution processing. So when you have to deliver applications with lower latency, where these application data is being processed becomes key, and that's where edge computing will have a bigger role. The 5G use case is the fact that it's actually catering to many different verticals, be it retail, manufacturing, entertainment, workplace use cases, or retail and healthcare use cases. These are also enablers of edge computing. And finally, the fact that in order to deliver these services much better, you need to have edge intelligence. And this is where you could make edge decisions using ML inference at the edge, but then all the learning and the training aspects of edge computing and AI happens more in the centralized cloud. So these are some of the key trends that you see. On the left side, you could it shows the growth in these different verticals going from 2020 to 2030. And you could see the manufacturing and the industrial sector is one of the bigger sectors here. Healthcare is also another key one. And today it starts with remote diagnostics and being able to deliver remote diagnostic sort of services with lower latency. But down the road, once you have a better air interface characteristics, you could eventually get to real remote surgery, which is one of the use cases that have been talked about for a long time, but realization-wise is likely in 6G or maybe even beyond 5G use cases before you could realize remote surgery. But you could always start with telehealth and remote diagnostics to begin with. And that's also a good use case of edge computing. And when we also look at the sector, there's a lot of work that's already happened in terms of establishing relationship between the telecom providers and the hyperscalers. So I've just picked AWS, Azure, and Google Cloud here, but of course there's other hyperscaler agreements in place with Oracle and IBM as well. And if we look at where this relationship has been established, it's primarily to do with mostly as a business relationship where the operator is providing the data center facility to the hyperscaler. Hyperscaler brings the infrastructure. In the case of AWS, it's the wavelength outpost kind of offering. Google has their own offering, same with Azure, Edge Stack offerings. But it's mostly been a relationship where the operator provides the infrastructure, the hyperscaler brings their own hardware and houses it on the data center that the operator is providing. And then you have third-party applications, be it gaming, or other use cases we talked about in the earlier slide, run out of this edge location. And then you have an economic model that's worked out between the hyperscaler, the app provider, and the operator, where the operator gets paid for the edge infrastructure, the infrastructure provider or the hyperscaler gets a portion of this revenue, and then eventually the app provider gets a portion. And this is where the terminal value of a service such as this can vary depending upon whether you're truly an end-to-end infrastructure or edge computing player, or you're just an enabler for edge computing. And when we look at where the terminal value could be delivered for some of these services, it's mostly where the intelligence is higher up that you could get higher terminal value for this edge service. And the reason why the hyperscalers and operators are marrying for this such services is because hyperscalers naturally have a lot more automation tools. The infrastructure is well tuned to bring up these new edge computing applications from third-party developers on this infrastructure. And finally, because it's an economic deal, it also goes back to the enterprise relationships that the hyperscalers already have. There are millions of enterprises that already run their services on the infrastructure that's provided by the hyperscalers, and being able to marry that relationship with what the operator could bring in terms of having edge infrastructure that's closer to the end user allows benefits for all players in this ecosystem. The next phase is something that I talked about earlier in the presentation as well, is you have a lot of different bodies working towards edge computing services. On the far left, you have a GSMA organization providing operator platform group and operator platform API group. So these are initiatives that GSMA is driving. And then there's industry initiatives around 5G Automotive Association. This is mostly for the car sector, automotive sector. NGMN, Bridge Alliance, and other associations that it's driving edge computing activity. And you have standardization, which has primarily been driven through ETSI-MEC, 3GPP, of course, and other newer ones, such as 1M2M, that's defined the services layer, the Web Consortium. And not to discount all the work that's happened in the open source community. And this is where, at least in the last several years, we've seen many of the open source initiatives collaborate and create joint initiatives. For example, a few years ago, there used to be open fog computing. Everybody used to talk about Acrano. But now many of those initiatives have been absorbed under LF Edge or ONAP, and CNCF is also there as well. Eclipse Foundation is more around IoT applications for the edge. And then finally, there are these alliances. So we hear about companies like Vapor.io, which is working on the Kinetic Edge Alliance. Seamster, which is another one that IBM originally started, which is focused again on edge computing. So the point that I'm making out of this slide is that there's a lot of work that's happening across these different industry associations, standard bodies, open source communities. And that's where the variety of use cases that can be supported is more, because these different players are there. But there's also which results in fragmentation. So there's no one central umbrella that's putting it all together, which is also a reason why edge computing has taken longer than some of the predictions have been made. So now I'll jump to the second section, which is more about the execution piece of this. How is actually edge computing being delivered? And more importantly, how it's being done out of the network edge, meaning the operator edge. And first, in terms of definition, you will often hear about two terms, public MEC and private MEC. Private MEC is where the edge computing use case is actually running on the enterprise location itself. So this you could categorize as deep edge, where the number of locations are in order of tens of thousands of sites. But it's actually located on-prem at the enterprise, and it's dedicated to the enterprise. Then you have public MEC use cases, which is actually shared sites, and that could be used to serve not just the enterprise, but could be used to serve the consumer as well. And this is where the operator infrastructure comes in. They have locations which are thousands of cell site locations, which could turn into an edge site. And now that gives the lowest latency because it's closest to the end user. But then you also have the far edge and aggregated edge locations. From a network terminology, you think about these locations as local data centers, regional data centers, and finally central data centers. And as you deploy the applications for edge computing in any one of these locations, the key factor is the number of locations in which the edge application can be deployed. Secondly, the latency and the experience that can be delivered out of this edge location. That's why you see a range of these infrastructure locations in which edge computing applications can be located and served out of. Now I'm showing an implementation of Open RAN here. And the reason why I'm showing Open RAN is because it's an open disaggregated interface. And one of the key aspects of Open RAN, outside of the fact that you're able to mix and match the radio unit with the baseband unit and can bring better vendor diversity, is also the radio intelligent controller. So think of the radio intelligent controller as an app store, similar to how Google and Apple have the App Store or Google Play Store. The concept is the device ecosystem is actually matured, and innovation is happening a lot more in that space. through applications that come from the long tail. So all the developers putting applications in Play Store or iStore has helped make the user experience on the end mobile device more. So in a way, you could argue that the device is now smarter than the network. And what the radio intelligent controller through the concept of an app store could do is bring that intelligence now into the network. And because you have a flavor of the edge radio intelligent controller that kind of runs closer to the user in what's called as the near real-time break, you could now host applications that are much closer and have a per user or per device sort of control mechanism in place. So when we look at the radio intelligent controller, there are two variants of this. One is called the near real-time break, and the other is a non-real-time break. And applications that are hosted in the near real-time break is what's called XApps, and applications that run on the non-real-time break is called RApps. Where the difference comes about is how close is the control loop. So if you're implementing an application where the control loop needs to be executed in less than a second, then you would run it on a near real-time break. And I'll talk later about some of these applications and how it's related to edge computing. And when you have longer control cycles, then you would run it in the RApps. And why this is critical for edge computing is because by the fact that you're removing some of the radio resource management and control functionality out into the centralized edge infrastructure or radio intelligent controller, you could now have third-party applications leverage the APIs that come out of these boxes to build applications that could be used for enterprise or consumer use cases. And this slide is showing a chart of the different use cases. I won't delve into each one of these use cases, but you could see here the variety of applications, so be it traffic steering. So traffic steering could be a very good application of edge computing where you need to steer the user to get better throughput, better latency, and that's critical for edge computing applications. So if a user is in a congested area, you could optimize the experience of the user, even though the rest of the users in that locality may not get the best experience. So using the quality of experience optimization XApp or using the traffic steering XApp, you enhance the end experience that the enterprise or consumer could leverage. And as you go higher up the value chain here in terms of intelligence, you use better algorithms, you use better machine learning and AI algorithms here to deliver a model which can deliver better results as opposed to a closed system. So we see Open RAN with radio intelligent controller, and the intelligence it brings into the network near the edge is one of the key building blocks for the operator to build intelligence at the edge of the network. And I've taken the example here from Dish, and it's a code which comes from Stephen Bai here that I've coded, where they talk about a lot of people ask what is the use case for the edge and what is the edge itself. And Dish says the edge in their case is the network itself, because they build out distributed open network. It's an Open RAN based deployment, and it's distributed, it's containerized, it runs in public cloud for the most part, except the cell site locations, it's physically closer to the user. So it's leveraging many of the elements that I talked about earlier in the slide, be it the hyperscaler relationship, Open RAN, radio intelligent controller. So all those elements are already part of their network, which is why Dish makes the claim that their network itself is the perfect use case of an edge computing. Now, eventually you monetize this through APIs, and that's what I'll cover in the next section of the presentation. And before I get there, just a quick view on what it takes to actually implement some of these edge intelligence use cases. There's a lot of machine learning expertise in RAN combined and mathematics here. So you would go through detailed network modeling, you would build algorithms that can deliver better performance, and then modify and retrain these models so that it gets better optimized over time. So you build a library of network intelligent applications that can be leveraged by the edge applications. And that could be a third-party developer or the operator themselves utilizing this edge application to run their network better and deliver better experience for the edge applications. So the last section is about edge economy and how it needs to be an API-driven, developer-first mentality, because this is a concept that's been there for the last decade, where operators have tried to monetize their network. It used to be simple use cases like location, expose the location capabilities and try to monetize that, or expose the capability to send an SMS. So there's all these concepts around CPaaS, communication platform as a service. It's companies like Twilio and others who were born out of the 4G rollout. So operators themselves could have done services like that, but somehow that opportunity was missed, and you had third-party players like Twilio being created as part of that 4G transition, and they've developed the applications now with the right set of APIs that the long tail has adopted. Versus the issue with the operator exposed APIs has always been the complexity of those APIs. So somebody has been able to abstract the information which comes from the network and give it in a form that regular developer who has no idea about how the network runs can consume. And that's where the success of players like the hyperscalers and the CPaaS providers have been in terms of differentiating how these APIs are. So I quickly wanted to give the audience a view of some of the initiatives that the operators have already. One of them is called Camara. It's an initiative that the operators in Europe have started. It's abstraction of the networks level APIs. And as you can see on the slide here, there's one level of abstraction that's the network level. And then there's a transformation function that's created and through an exposure gateway function, you expose service APIs. And the whole idea here is these service APIs are the ones which the developers can easily consume. If the developers have to directly consume the network API, then it becomes a lot more cumbersome. They need to know the network, and that's not going to result in a big adoption. So this effort at Camara is trying to solve for that. And one of the initial use cases is QoS on demand. That's what you see on the left, a QoD, a QoS on demand. Another aspect when we think about RIC is the radio intelligent control of Open RAN is whether you develop this as an SDK or API. And our view from Mavenir standpoint, and generally what we've been advocating in the industry, is that you need to have APIs so that it can be programming language agnostic and you're not tied to a particular platform. That way, the applications, be it the X apps or R apps that's developed by one party, could run on different parties' platform, the RIC platform. So having talked about it, there's still a lot of challenges that needs to be addressed, and it has to do with one of the key ones that I'll talk about on the slide is the edge platform. And this has to do with, as operators, multiple operators that are in the mix doing edge application, for an end user, it does not matter. So if I go sell a service like service to the Mercedes-Benz, and when the Mercedes-Benz lands in a T-Mobile network or an AT&T network, or when they're roaming in Germany on a Deutsche Telekom network, they want to get the best experience. So edge federation, how edge experience works across different operators is something to be worked out. And this is one of the complex areas of edge computing. Same with roaming, and finally how QoS gets handled, how the end-to-end performance gets handled, and how mobility when applications, when the application that's residing in the mobile device moves from one cell site to the other, how do you maintain the user experience? So these are some of the areas that as an industry we're looking to solve in edge computing. Over time, it would get solved. And as I talked about earlier, it's a big market, and Mavenir is working with the ecosystem, with the app providers, the system integrators, and finally our customers, the operators, the enterprises, and consumers to actually develop and solve some of these issues that are shown on the slide. So thank you for listening to the presentation today.
Thank you, Bejoy. We really made some interesting points there, particularly around that overlap between Open RAN and edge computing, and how kind of thinking holistically about your network architecture creates an opportunity for an operator to improve their own operational efficiencies, save money that way, and kind of pave the way for new service revenues. So really appreciate the presentation and your time today.
Thank you. Thanks, Simon.